Okay, that'll be for the next 5 minutes. Then let's learn about static electricity. Are we logged in? Yes, we're logged in. Subtitles. Let's see. What's up?
We see there like the balloon suspend. When we start like a little video, there is a
Other videos?
yeah.
Yeah, they're just other videos. There's a lot of them. It's a little bit loud, huh? You know what? I think somebody turned up my volume again. No? Oh, that's normal. Okay. There we go.
It can strike without warning. At any moment, you may be walking across a soft carpet and reaching for the doorknob when suddenly, zap. To understand static electricity, we first need to know a bit about the nature of matter.
Right. So the first thing, you walk across a carpet, you touch a door, that's shock. That's static electricity.
All matter is made up of atoms that consist of 3 types of smaller particles: negatively charged electrons, positively charged protons, and neutral neutrons. Normally, the electrons and protons in an atom balance out, which is why most matter you come across is electrically neutral. But electrons are tiny and almost insignificant in mass, and rubbing or friction can give loosely bound electrons enough energy to leave their atoms and attach to others, migrating between different surfaces. When this happens, the first object is left with more protons than electrons and becomes positively charged, while the one with more electrons accumulates a negative charge.
Okay, so there's a lot of things here. Let's try to explain it slowly. So everything in the world has matter. And matter always has some protons, which are positive, some electrons, which are negative, and some neutrons, which are not positive, not negative. So let's just say your hair, for example. Maybe your hair has like 500 protons and let's say 500 protons and 500 electrons. Okay? Electrons are very small, very light. So when you scratch your hair, maybe some electrons come off. Then, after you scratch your hair, now you have 450 electrons. So, 500 protons, 450 electrons, the whole thing, your hair, becomes positive. And there's a bunch of electrons coming off your hair onto your hand. Now your hand is becoming negative because it has a lot of electrons. So, there's now electricity in your hair and electricity on your hand. What happens?
This situation is called a charge imbalance, or net charge separation. But nature tends towards balance. So, when one of these newly charged bodies comes into contact with another material, the mobile electrons will take the first chance they get to go where they're most needed, either jumping off the negatively charged object or jumping onto the positively charged one, in an attempt to restore the neutral charge equilibrium. And this quick movement of electrons, called static we recognize as that sudden spark.
Okay, so nature, things like to be in equilibrium. Equilibrium means not positive, not negative, balance. So things want to be in balance. So if you touch something and it has extra electrons, it's negative, those electrons will come onto your body. When a bunch of electrons come onto your body, bzzz, that's a shock. That's a static. Something like that.
This process doesn't happen with just any objects. Otherwise, you'd be getting zapped all the time. Conductors like metals and salt water tend to have loosely bound outer electrons, which can easily flow between molecules. On the other hand, insulators like plastics, rubber, and glass have tightly bound electrons that won't readily jump to other atoms. Static buildup is...
Okay, so, right, she mentioned two kinds of scientific words. Conductors and insulators. So, did you hear what are some examples of conductors?
Like touch the
Yeah.
rubber.
No. So rubber and plastic, they are insulators. Conductors are things like metal. And human skin is also a conductor. So things like metal, salt water, human skin, those are conductors. Conductors give electrons easily. Insulators do not give electrons easily. So that means which one gives off more electricity? What are you pointing to? Conductors or insulators? Conductors, right. Conductors give off more electricity.
It's most likely to occur when one of the materials involved is an insulator. When you walk across a rug, electrons from your body will rub off onto it, while the rug's insulating wool will resist losing its own electrons. Although your body and the rug together are still electrically neutral, there is now a charge polarization between the two. And when you reach to touch the doorknob, zap! The metal doorknob's loosely bound electrons hop to your hand to replace the electrons your body has lost. When it happens in your bedroom, it's a minor nuisance. But in the great outdoors, static electricity can be a terrifying, destructive force of nature.
Okay, so to review. So carpets, they're made of wool, they're good insulators. That means they do not lose electrons. The human body is a conductor, so the body loses electrons. If your body loses electrons,
Insulating wool will resist losing its own electrons. Although your body and the rug together.
so body plus rug together is neutral, 0. But
Other are still electrically neutral.
but each one is different. The carpet is negative. It has a lot of electrons. Your body is positive. It's plus. It has too few electrons. When you are positive, you want more electrons. That means if you touch metal, which is a conductor, the metal says, "Here, take my electrons." And then you take the electrons and what happens?
And
That's right, you get shocked. Like that, yeah. That's the short bit.